Chapter 6, Gradient and Area under a graph. So for 6.1, quantity represented by the gradient of a graph. For this chapter, we are going to learn two graphs. First type of graph will be distance against time graph. So this is read as distance against time. For distance against time graph, we will have y-axis as distance and time as x-axis. This is the unit for distance, meter, and this is the unit for time, second. The gradient of a distant time graph is speed. Okay, so to find the gradient, we must at least have 2 points. The coordinate of this point will be x2, y2. The coordinate of this point will be x1, y1. So to find gradient equals to y2 minus y1 over x2 minus x1. This is the formula for you to find the gradient. y2 minus y1 over x2 minus x1. So y2 minus y1. This is the change of vertical distance. And for this graph, the vertical y-axis is distance. So you have change of distance. And then x2 minus x1. x2 minus x1. This is the change of horizontal distance. For this graph, the horizontal is time. So you will have change of time. Change of distance over change of time. This is speed. Distance over time is speed. This is the unit for distance, meter, and this is the unit for time, second. So the unit for speed will be meter per second, ms power negative 1. A steeper line has a greater gradient, means greater speed. Okay, for example here. So to find the gradient, we must have at least 2 points. So let's say the coordinates of this point is 6, 8. And the coordinate of this point will be 2, 1. So the gradient of this graph M equals to y2 minus y1. So 8 minus 1 over x2 minus x1, 6 minus 2. 7 over 4 meter per second. So the speed of this graph is 7 over 4 meter per second. And how about the second graph? Second graph here has a less steeper line. A shallow line has a smaller gradient, means smaller speed. For example, to find the gradient, we must at least have 2 points. So let's say this 2 points. The coordinate of this point is 2, 2. The coordinate of this point is 6, 3. Then to find the gradient, y2, m equals to, m is gradient, y2 minus y1, 3 minus 2, over x2 minus x1, 6 minus 2. Then you will have 1 over 4 meter per second. Okay, you compare these two. 7 over 4 is obviously greater than 1 over 4. Therefore, this graph has a greater speed compared to the second graph. A steeper line means that it has a greater speed. A shallow line means that it has a smaller speed. Then how about a flat line? A flat line has no gradient. Therefore, speed equals to 0. Means that the object is not moving at all. So let's say to find the gradient of this graph, we must at least have 2 points. So the coordinate of this point, for example, this is 5, 5. And then the coordinate of this point, let's say this is 2, 5. Okay, this is 5. And this is 2, 5. If we want to find the gradient, it will be y2 minus y1, 5 minus 5 over 5 minus 2. Then you will have 0 over 3 equals to 0. The speed is 0, therefore this object is not moving at all. Example 1. Briefly explain the motion of RD from O to R. So we break it into 3 parts. First part is from O to P, second from P to Q, third from Q to R. So this is a distance over time graph. The unit for distance for this graph is kilometer. The unit of time is second. Okay, so first we look at OP. To find the gradient, we must at least have 2 points. So let's say these 2 points. The coordinate of this point is x2, y2. The coordinate of this point is x1, y1. To find the gradient, we use y2 minus y1 over x2 minus x1. Then you will have a positive number. So for all p, Ali is moving with a constant speed. PQ. We must at least have 2 points to find the gradient. So let's say the coordinate of this point is x1, y1. The coordinate of this point is x2, y2. To find the gradient, we use y2 minus y1 over x2 minus x1. But since y1 and y2 here are the same, because they are from the same y coordinates here. Therefore, y2 minus y1, you will have 0. So the answer is 0. So gradient equals to 0 means that speed equals to 0. Therefore, Ali is not moving at all from the time P to time Q. From Q to R, gradient equals to y2 minus y1 over x2 minus x1. So if you put in any values here, you will have a negative value, negative answer. So Ali is moving with a constant speed but in opposite direction. Okay, negative answer here means that Ali is still moving but he is in opposite direction. Okay, so the whole picture is like this. Ali start from O, he start moving from O to P. With a constant speed. And then from P to Q, he stay at the same place. He doesn't move because the gradient of PQ is 0. Therefore, Ali is not moving at all. So he just stay at the same point. So this is also Q. After that, from Q to R, we found that the gradient is negative. Therefore, Ali is moving with a constant speed but in opposite direction. So this means that Ali, he walks back to the original position. He walks back to O, to the origin. So from Q, he walks until R, which is also the origin O. So this is the formula for you to find the average speed, which is equals to total distance traveled over total time taken. Example 2. Diagram shows a graph of distance against time for the motion of a car. Find the speed of the car for the first 6 seconds and B from 6 to 15 seconds. Okay, so we have to find the speed. Find the speed of the car for the first 6 seconds. So to find the speed distance against time graph, we just need to find the gradient. To find the gradient, we must at least have 2 points. So let's say this point and this point. The coordinate of this point is 6, 12. Okay, the x is 6, y is 12. So 6, 12. The coordinate of this point is 0, 0. Then the gradient will be 12 minus 0 over 6 minus 0. Okay, you will have 12 minus 0 over 6 minus 0. So 12 over 6. This is the unit even. Distance is meter, time is second. So you just write down here meter second. So 12 divided by 6, you will have 2. The unit is meter per second. So from O to this point, the speed of the car is 2 meter per second. Means that in 1 second, the car can move 2 meters. Then B, the speed of the car from 6 to 15 seconds. Okay, so we have to find the gradient for 6 to 15. So here, to find the gradient, we must at least have 2 points. So let's say the coordinate of this point is 15, 12. The coordinate of this point is 6, 12. Then the gradient will be 12 minus 12 over 15 minus 6. So you will have 12 minus 12 is 0. 15 minus 6, 9. The unit given is meter and second. Meter second. Therefore, 0 divided by 9, you have 0 meter per second. Means that from 6 to 15 seconds, the car is not moving at all. It just stays at the same place. This is the second graph that we need to learn. Speed against time graph. Okay, so for y-axis, you will have speed. For x-axis here, you will have time. The unit for speed is meter per second. the unit for time is second. The gradient of a speed against time graph is acceleration, or we can call it as rate of change of speed. Okay, so this is the graph of speed against time. So if we find the gradient, we must at least have 2 points. So let's say this point is x2, y2, and the coordinate of this point is x1, y1. Then to find the gradient, we just use the formula of the gradient, y2 minus y1 over x2 minus x1. So you will have this y2 minus y1 over x2 minus x1. y2 minus y1 is the change of vertical distance. Then from this graph, the vertical is speed. So you will have change of speed. Then x2 minus x1 is the change of horizontal distance. From this graph, the horizontal is time. Then you will have change of time. Change of speed divided by change of time. Speed is meter per second, time is second. Speed against time is acceleration. The unit is meter per second per second. Because x here is power 1, then you have to minus 1 to this. Therefore, you will have meter per second mx power negative 2. A steeper line has a greater gradient, means greater acceleration. A shallow line has a smaller gradient, means smaller acceleration. Okay, so you compare these two graphs. So this is speed against time graph, speed against time graph. For the first graph, it has a greater acceleration. This triangle is bigger. Okay, or you can say that this line is steeper. Therefore, for this one, it has a greater acceleration. For the second graph, this line is shallower. It's less steeper compared to the first graph. The triangle here we formed to find the gradient is smaller. Therefore, for this graph, it has a smaller acceleration. A negative gradient means deceleration. So if you have a graph that the line is going down, then this graph will have negative gradient. Negative gradient means that for this graph, it is deceleration. Last one, a flat line has no gradient, means acceleration equals to 0. So for a flat line, we can't find any gradient. The gradient equals to 0. Therefore, acceleration equals to 0. But the object is still moving because it still has speed. Just the object is moving with same or constant speed. Okay, the object is still moving, but with a same speed. Okay, it's different from the distant time graph. For distant time graph, if you have, okay, this is distant time graph. If you have a flat line here, the gradient is 0. Therefore, the speed is equal to 0. For distance over time graph, this object is not moving at all. It just stays at the same place. But for speed against time, if you have a flat line here, means that the object is still moving, but with the same speed. So that's the difference between distance against time graph and speed against time graph. Okay, so let us look at the example. Example 3. Briefly explain the motion of Hansen from O to R. So we also divided it into 3 parts. First part is from O to P, from P to Q, and from Q to R. So you have to notice that this is a speed against time graph. If you find the gradient of speed against time graph, the gradient will be acceleration. Okay, so from O to P, so we have 2. So we must have at least 2 points here. Let's say this is x1, y1, and the coordinate of this one is x2, y2. To find the gradient, y2 minus y1 over x2 minus x1, then you will have a positive number. Therefore, Hansen is moving with increasing speed, or you can say he is accelerating. From P to Q, okay, the coordinate of this point is x1, y1, the coordinate of this point is x2, y2. But since y1 and y2 are the same, so y2 minus y1 you will have 0. So the answer, the gradient is 0. Gradient 0 means that acceleration equals to 0. Therefore, Hansen is moving with constant speed. He's still moving, but just he is moving with constant speed, same speed. From Q to R, so let's say the point is x2, y2. This point is x1, y1. So y2 minus y1 over x2 minus x1. You will have a negative number. Therefore, Hansen is moving with decreasing speed, or you can say Hansen is decelerating. His speed is smaller and smaller. Okay, example 4. Diagram shows the graph of speed against time graph of a moving car for 5 seconds. Find the rate of speed change when the car travels from X to Y and B from Y to Z. Okay, so from the question, we are asked to find the rate of speed change. The rate of speed change is also known as acceleration. Find the acceleration of the graph. Okay, find the acceleration of the car when it travels from X to Y or from Y to Z. Okay, so from here, the gradient of a speed against time graph is known as acceleration or rate of change of speed. So from this question, we are asked to find the gradient for this speed against time graph. So for A, X to Y, here is 0, 20. The coordinate of this Y here is 4, 5. Okay, we draw a triangle here. Then the gradient will be 20 minus 5 over 0 minus 4. 20 minus 5 over 0 minus 4. Then you will have 15 over 4. This is the unit. The unit for speed given is meter per second. The unit of time is second. Therefore, the unit of this gradient is meter per second per second. So you have negative here. Negative gradient means the speed is decreasing. Therefore, the car from X to Y, the car is decelerating. B, from Y to Z. So we also do the same thing. The coordinate of Y is 4, 5. The coordinate of Z is 5, 10. Then you just find the gradient. 10 minus 5 over 5 minus 4. Then you will have 5 over 1 equals to 5. The unit is meter per second per second. Okay, so this is a summary. We have learned two types of graph. Distance against time graph and also speed against time graph. First one, for distance against time graph, if we find the gradient, then the gradient will be speed. Okay, because change of distance over change of time. Distance over time is speed. Okay, with the unit of meter per second. Second type of graph is speed against time graph. So if we have speed against time graph, then we find the gradient. The gradient is equals to the acceleration, because change of speed over change of time equals to acceleration. Okay, with the unit of meter per second, which is meter ms power negative 2. Quantity represented by the area of the graph. Okay. For this section, we only use one type of graph, which is speed against time. So for speed against time graph, the quantity represented by the area under the graph is distance. So for example, here we will have speed against time graph. So if we find the area under the graph, then this area is represented by the distance traveled. Okay, for example, calculate the distance of the graph. So to find the distance of speed against time graph, we just need to find the area under the graph. So we also notice that this area under the graph, this is a triangle. So we use the formula of area of triangle. So area of triangle equals to 1 over 2 times base times height. The base here is 7 minus 0, 7. Height is 6 minus 0, so 6. So the area of this triangle is 1 over 2 times 6 times 7, which is 21 meter. Another example, calculate the distance of the graph. To find the distance of speed against time graph, we just need to find the area under the graph. So we notice that this is a rectangle. So we just use the formula of a rectangle. Base times height. The base here is 6. Height is 4. So 6 times 4, you will have 24 meter. Another example, calculate the distance of the graph. So for speed against time graph, if you want to find the distance, then we just find the area. And this is a trapezium. So use the formula of a trapezium, which is 1 over 2 times sum of the two parallel sides times height. Okay, so this is the parallel. So these are the parallel sides. This is 6, well, this is 4. And this is the height. H equals to 8. Then you just put in the formula here. 1 over 2 times 4 plus 6 times 8. Therefore, the answer is 40 meter. Okay, so example 8. Diagram shows the speed against time graph of a moving object for 15 seconds. Set the length of time in seconds that the particle move with constant speed. And B. Calculate the rate of change of speed in meter per second in the first 3 seconds. C. Calculate the average speed of the object in 15 seconds. Okay, so to do this kind of question, we have to highlight the keyword. Okay, so let's say I highlight the keyword. For A, the keyword is length of time. Move with constant speed. So we have to identify what type of graph is this. So this is a speed against time graph. Okay, for speed against time graph, if you want to find the constant speed, that means it is a flat line. Here. From 3rd second to 9th second, this object is moving with constant speed. Therefore, the answer for A, find the length of time, is 9 minus 3, 6 seconds. Okay, so the answer is 6 seconds. Okay, B. Calculate the rate of change of speed in the first 3 seconds. So this is a speed against time graph. To find the rate of change of speed, which is also acceleration, we have to find the gradient for the first 3 seconds. So you just focus on first part here, P. So to find the gradient, we must at least have 2 points. So let's say this point is 3, 6, and this point is 0, 3. And this point is 0, 3. To find the gradient, 6 minus 3 over 3 minus 0. And you will have 3 over 3, which is 1 meter per second. C. Calculate the average speed of the object in 15 seconds. Okay, to find the average speed, we have to use the formula. Average speed equals to total distance traveled, total distance over total time. So total time is 15 seconds. So now we have to find what is the total distance traveled. To find the total distance traveled for speed against time graph, we have to find the area under the graph. So we just divide this graph into 3 parts, which is P, Q, and R. Okay, for P, this is a trapezium. So area of trapezium, P. For Q is a rectangle. So plus area of rectangle. And R is area of a triangle. Then you find for trapezium, this is the parallel, these are the parallel side. This is 6, 3, and the height here is 3. So 1 over 2 times 6 plus 3 times 3. The rectangle here is, okay, this is 6 times 6. And then this triangle is 1 over 2 times base times height. And you have this one. Therefore, the total distance traveled will be 67.5 meters. So the average speed is total distance over total time. So just put in the value that we have found, 67.5 divided by total time travel, 15. So equals to 4.5 meters per second.